Hey, how you doing? So today's topic is going to be respiratory system. So let's get started. So beginning with today's lecture, we'll cover respiratory system under two parts. The first part where we'll cover these topics, and the other part where we'll cover the regulation, the exchange of gases and the applied aspect. So in today's video, we'll be covering introduction, mechanics of breathing, spirometry, lung compliance and work of breathing, and surface tension and surfactant. So starting with the introduction of this chapter mainly concerns about how the exchange of gases takes place and how the gases are transported to the tissues for their usage. So that is the oxygen that is used by the body to perform various actions. Beginning with the introduction, first we'll cover the components of respiratory system. So the components of respiratory system include right from the nose, your pharynx, your trachea, the trachea that bifurcates into bronchi, and the divisions of bronchi further down up to the alveolar sac that goes via terminal bronchioles and everything. And then we'll cover the functional anatomy that tells us about the lungs and the structure about the lungs, that is the pleura that covers the lungs. Beginning with components of respiratory system, it's divided into two parts: upper respiratory tract and lower respiratory tract. So upper respiratory tract is all that is from your nose up to your trachea, and specifically in the trachea up to your glottis. That is the upper respiratory tract. So upper respiratory tract mainly has a function of transport of gas, and it mainly humidifies the gas and converts the gas to the normal body temperature. So that is what the function of upper respiratory tract is. Lower respiratory tract includes everything below the glottis, that is the lower part of trachea, the bronchi, bronchioles, terminal bronchioles, and the alveolar sacs, and it mainly pertains to the exchange of gases and removal of carbon dioxide from the blood. And lower respiratory tract can be said to be divided into 23 generations. So what these generations mean is basically divisions of the trachea, divisions of the bronchi into bronchioles, terminal bronchioles, alveolar sacs, alveolar ducts and alveolar sacs. So from these 23 generations, the first 10 generations of the divisions contain cartilage. The function of cartilage is to provide support. In anatomy, the trachea is placed in front of esophagus. Okay, so if the cartilage that is present here prevents it from, the C-shaped cartilage that is present over here keeps the trachea sturdy and stiff so that it doesn't collapse. And it is, if you notice, I said C-shaped, and it's not a complete ring because posteriorly it is related to esophagus. And if there is a cartilage behind, the esophagus may get damaged, or it may hinder the movement of food from the esophagus. Okay, so the first 10 generations of the tract contains cartilage. This was about the first 10 generations. The other way to classify lower respiratory tracts are in two: 1 to 16 and 17 to 23. 1 to 16 are called the transport or the tracts or the generations where only the gases travel through. There is no exchange of gases occurring over here. So this is where only the gases travel and no exchange takes place. 7 to 23 is the respiratory zone. That is the part where respiratory gases exchange, that is oxygen and carbon dioxide exchange from the alveoli to the blood and other way. From 17 to 23 we can further classify them from 17 to 19, 20 to 22 and 23rd generation. So I'll tell you what this means. 17 to 19th generations, these are the respiratory generations or the respiratory tracts that where only some amount of exchange of gases takes place, not much but just a few. 20 to 22 are known as alveolar ducts. These ducts connect alveolar sacs to the main respiratory zone. So these are places where relatively higher amount of gas exchange take place. And the third part is the 23rd zone, 23rd generation, that are the alveolar sacs. That is where the maximum amount of exchange takes place and the majority of the exchange takes place. These alveolar sacs are the alveoli. There are 300 million alveoli present in your each lung. So that if to explain it to you how many they actually are, if you spread them out, if you put them on a piece of paper, not actually a piece of paper, or on the ground, they can cover up to 5 to 10 meter square area. Okay, so this was about the components of respiratory system. Now coming to the functional anatomy. In functional anatomy, the lungs have two coverings. The two coverings are known as pleura, and the two coverings are parietal pleura and visceral pleura. So what these mean? Viscera means any organ, means any internal organ. So any covering that immediately covers the organ is known as visceral, and since it is lungs, it's called pleura. So visceral pleura is the covering that immediately surrounds the lungs. And there is the other covering known as parietal pleura that surrounds the visceral pleura. There is a space between both of them that is known as intrapleural space. This space contains intrapleural fluid, which we'll cover in the later topic, that allows to reduce the friction and assists in breathing. So what's the importance of these two coverings? The parietal pleura is rich in blood supply, whereas visceral pleura is not rich in blood supply. So as you can figure out, the parietal pleura that contains the blood supply also give nourishment to the lungs. Okay, and it is the blood supply to the parietal pleura which filters out to form the intrapleural fluid. Okay, so that is what is the importance of parietal pleura and visceral pleura. Visceral pleura, as I said, is immediately surrounding the lungs, so it cannot be separated. While you do dissection in anatomy, you will separate a covering from the lungs. The covering that you separate, that is going to be the parietal pleura and not the visceral pleura. Okay, so visceral pleura is adhered to lungs very firmly and you cannot remove it. Okay, so that covers the components of respiratory system and functional anatomy, and that concludes the introduction of a chapter to the respiratory system. So before moving on to the next topic, that is mechanics of breathing, first let us discuss the functions of lungs. The functions of lungs are respiratory and non-respiratory. The obvious respiratory functions of lungs are exchange of gases. The non-respiratory functions include that it serves as a reservoir for the blood from the left ventricle. How and why we'll discuss in another topic known as pulmonary circulation. The next non-respiratory function is it serves as a filter for an emboli. An air emboli can be introduced due to some various reasons in the blood. If it is introduced, it can be removed because the air is exchanged in the lungs, so that extra air or the air bubble that is present in the blood vessel, if it is small, it can get removed easily. The other functions are, it serves as an endocrine function. So it converts angiotensin 1 to angiotensin 2. That is that you will study in the renal physiology, where it is, and it also in the cardiovascular physiology, where it is used to maintain blood pressure. So the lungs possess an enzyme known as angiotensin converting enzyme that converts angiotensin 1 to angiotensin 2. The other non-respiratory functions are biochemical functions. It synthesizes something known as surfactants that we'll study in another part of this chapter only. Okay, so now moving on to the mechanics of breathing. So mechanics of breathing, before actually seeing how the lungs help in the breathing, we'll see the various components that are the stuff that helps the lungs to actually exchange the gases, that is the muscles and the different pressures in the lungs. So muscles of respiration. So there are, if we can classify, the muscles are for inspiration and expiration. For inspiration, the inspiration, so first we'll define what is inspiration. Inspiration is the process where the air from the atmosphere enters the lungs. Expiration is where the air from the lungs go out to the atmosphere. Okay, so in inspiration is an active process and expiration is a passive process. Okay, so inspiration has two types of muscles, that are the primary and the accessory muscles. The primary muscles are the muscles that are mainly involved in normal breathing. Accessory muscles are those muscles that help in forced breathing or above extra breathing. Okay, so the primary muscles are the diaphragm and your external intercostal muscles. The external intercostal muscles are placed between your two ribs. That will study in anatomy, the location and everything. So diaphragm and external intercostal muscles are the two main muscles that helps you to inspire. The other so how it actually helps is, so in this diagram you can see this is the diaphragm and this is the chest wall or the thoracic cage. The diaphragm contracts. The diaphragm normally is a dome shaped structure. Okay, so contraction of diaphragm makes the diaphragm from a dome shape to a flattened state. So that means the diaphragm moves downwards like this and it becomes flattened. Okay, so it becomes flattened. The external intercostal muscles pulls the thoracic cage outwards. So if it pulls the thoracic cage outwards, the thoracic wall changes its shape from this structure to this structure. So as a result, you can see the volume of thoracic cage has increased. This increase in the volume of thoracic cage leads to a decrease in the intrapleural pressure. So we'll discuss it in much detail about that over here, but just remember that increase in the volume of thoracic cage leads to a decrease in intrapleural pressure. So decrease in intrapleural pressure causes a negative pressure inside the lungs, and due to this negative pressure that is created inside the lungs, the air from the outside enters inside. So that is how normal inspiration takes place. The other accessory muscles involved in inspiration are the scalene muscles, the sternocleidomastoid, the abdominal muscles. These muscles help in breathe in over and above the normal breathing. Okay, so now coming to expiration. As you recall, I initially said expiration is a passive process. That means there is no active use of muscles to expire. Okay, so what happens is, once the muscles have contracted, the muscles relax. The relaxation of these muscles leads to an increase in the intrapleural pressure. That is, it becomes less negative. Since it becomes less negative and the volume of thoracic cage also decreases and comes back to normal, the decrease in the thoracic cage volume and the increase in the intrapleural pressure causes the flushing out of the air from the lungs to the atmosphere. So the air moves outside. So, and expiration normally, as I said, it's passive, doesn't require any help. If there's a forced expiration, if you want to purposely expire more, these same muscles, the same abdominal muscles also help in the expiration. And the internal intercostal muscles, help in the expiration. Okay, so that is the role of muscles in respiration. The main role, if you want to just summarize in one statement, what is the role of muscles of respiration? It is to change volume. It is to change volume, which further changes the pressure. Okay, so now moving on to the pressures involved in the respiration. The three main pressures involved are intrapleural, transmural and alveolar. So as I earlier said, intrapleural pressure is the intrapleural pressure. It's due to the fluid present in the intrapleural space. The intrapleural space is the space between parietal and visceral pleura. So this is the visceral pleura, this is the parietal pleura. This is the intrapleural space that has the fluid, and this fluid exerts a pressure on the two membranes. This is known as the intrapleural pressure. And by default, intrapleural pressure is always negative. Why is it negative? To explain you, I'll just give you an example. Imagine this is a lung. The lungs are elastic. Okay, so lungs have a tendency to recoil, just like a rubber band. How you expand a rubber band and you release it. Sorry. So when you release it, it becomes normal and becomes less in size. So it has the elastic property to recoil. Just like that, the lungs also have elastic property to recoil. That is why it decreases in size. But the thoracic cage, it's the exact opposite. The thoracic cage have a normal tendency to expand. Okay, so if you can imagine, there's a force that's trying to contract, there's a force that's trying to expand. So these two are opposite forces. These are two forces acting in opposite direction, and this pulls the two membranes apart. This pulling of two membranes apart creates a suction force, and since it's a suction force, it has to be negative. Okay, so that is why it is negative. And these forces are perfectly balanced. Since they are perfectly balanced, it doesn't happen that one moves out extremely out and the other one is loose from it. This only happens in diseased conditions or some other known as where the lung collapses. We'll see about that in the applied aspect. Okay, so this is why the intrapleural pressure is negative. It is something where two forces are acting in opposite direction, pulling them apart. That causes a force. That causes a suction force, and this force is known as the pressure exerted due to this force per unit area is the intrapleural pressure. So value of intrapleural pressure during inspiration is minus 8 centimeter of H2O, and during expiration it is minus 5 centimeter of H2O. So as you can see, it becomes more negative during inspiration. Since it is more negative, it creates a more suction force and it pulls the air inside. So that is how the intrapleural pressure helps in breathing. It helps in inspiration. Okay. So then coming on to the transmural pressure. The transmural pressure is of two types: transpulmonary or trans airway. So transpulmonary, as the name suggests, it's across the lungs. Okay. So transpulmonary pressure can be mathematically represented as the difference of alveolar pressure and the pleural pressure. Okay, so that is a difference between alveolar pressure and pleural pressure. Alveolar pressure is the pressure that is exerted by the gas present in the alveoli. Okay, that's the alveolar pressure. And the pleural pressure, that is the pressure exerted by the intrapleural space. Okay, the difference of these is known as transpulmonary pressure. And transpulmonary pressure by default is always positive. Why? I'll tell you. So if we add the value, the alveolar pressure during when there is no exchange of gas, taking place, the alveolar pressure is 0. Okay, so alveolar pressure becomes 0, and as we said, intrapleural pressure is always negative. So we add a negative sign, minus 8 during inspiration. So transpulmonary pressure becomes plus 8 centimeter H2O, and this is true in every case. Okay, so due to this, transpulmonary pressure is always positive. Trans airway pressure, as the name suggests, it's the pressure difference across a airway, that is your trachea. The pressure difference across trachea is known as trans airway pressure. It does not have really much of a significance. It's just to explain. It doesn't have much significance in during mechanics of breathing. It has importance when there is no breathing taking place. So what does that mean? When there is no breathing taking place, that means there is no exchange of gases, there is no movement of air in the conducting part. So if there is no movement of air, the conducting part does not have to collapse. If it collapses, the further inspiration would require much more energy. To prevent that, there is trans airway pressure. The trans airway pressure keeps the airways open at all times. This is the importance of trans airway pressure. It does not directly affect the breathing part, but it affects when the lungs are not involved in transport of gases. Okay. Then the third part, that is the alveolar pressure. As I said, alveolar pressure is the pressure inside the alveoli exerted due to the air present. During inspiration, it goes up to minus 1 mm Hg, and during expiration, it is plus 1 mm of Hg. Okay. Now, one more thing about intrapleural pressure is, I forgot to mention over here, the intrapleural pressure does not just specify the pressure difference across the pleuras. It also helps us to know the pressures between different sites, like the pressure difference across the interstitial zone, the pressure across esophagus. It also helps us to know the transesophageal pressure, and it also helps us know transesophageal pressure. Why is this important? Why is knowing transesophageal pressure so important? Because we cannot directly measure intrapleural pressure. To do that, we would have to insert a needle between the pleural space, and that's quite risky. So we do not want to do that. So instead, we measure the pressure across the esophagus. That is the transesophageal pressure. And since intrapleural pressure reflects transesophageal pressure, we indirectly measure intrapleural pressure by measuring transesophageal pressure. And the importance of transesophageal and intrapleural pressure we'll see in the compliance diagrams. Okay, so that is all about this is about the components of mechanics of breathing. So these are all the factors that affect how you breathe. So now seeing the actual process of breathing. Okay, so the actual process of breathing begins with the first step, that during inspiration it begins with the contraction of what? Diaphragm and your intercostal muscles. Okay, contraction of diaphragm and intercostal muscles. What do? They increase the volume. They increase the lung volume, and this increase in lung volume causes a decrease. It causes a decrease in pressure. This causes a decrease in pressure, which allows the air to move in. This is the basics of inspiration. This is how normally inspiration takes place. If you want to do a forced inspiration, the other accessory muscles also take part and helps you to inhale much more amount of air. Expiration is the exact opposite of this, where there is no contraction, there is relaxation. There is no increase in volume, there is decrease in volume. There is no decrease in pressure, there is increase in pressure. This increase in pressure pushes the air outside, and these all factors are the various factors that assist you, that help in the breathing. So this concludes the mechanics of breathing. And now moving on to the next part. I hope this made sense. Now you can go back and refer to your books. I'm sure you'll understand this much more better, and I'll see you in the next one.